Hello, in this lesson, I'm going to review evaluating formulas. So the three main objectives. One is evaluate some basic formulas. And objective 2, I'm going to evaluate formula involving the form involving plus and minus symbols. And the third one, I'm going to evaluate formula involving summation symbols. All right, let's do some basic one first. Here again, I'm going to focus on evaluating using your calculator. So I have expression C equal to 1.25 times t plus 4.25 here. To evaluate something like this, notice that when there's nothing in between here, tells me to multiply, meaning that 1.25 times t. So when t equal to 6, I can plug it in. So 1.25 times 6 give me 7.5, and write it down the next one. All the operation tells me multiply first and then add them, give me 11.75. Right? So I can do the same thing here using a calculator. Right? So let me do this one using a calculator. Okay. So for example 2. So first I'm going to substitute. So we have t is equal to 2.25 times m. M in this case has 15. Notice that I use a parenthesis around the decimal, so just don't get confused as multiplication sign, plus 1.25. And then I'm going to substitute that into the calculator. Let me clear it. So here I would have 2.25 times 15, so 2.25 times 15. I'm going to add 1.25. Okay, plug it in. I'll get an answer of 35. Right. So the answer is 35. Let me write it. So that temperature is 35. Now, would it be what would be a conclusion sentence if m represent mile and t represent a total cost of a taxi ride? Okay, m represent mile, so that means this is 15 m equal to 15 mile. And t represent cost, right? Cost for a taxi ride. Well, think about, so if you have ride a taxi for 15 mile, the cost would be $35. Let me write that. So I can say the total cost for a 15-mile taxi ride is $35. Now, for the next few exercises, we're not going to worry about the content here, so no conclusion sentence needed. But remember, in statistics, you often need to use proper units and conclusion sentence. Also, try and use your calculator to find the answers. So here again, I'm going to focus on the use of calculator to evaluate each expression. But before I take out my calculator, I'm just going to substitute it in the variable first for the numbers. So sigma equal to s over square of n. S is equal to 18.4. So you can type in 18.4. And square root n is 15. I'm going to round the answers to 2 decimal place. If you calculate it, you see the answer is approximately 4.75. All right, let me show you how it's done in the calculator. I always like to clear the window before I do evaluate a problem. So I have 18.4. I just have one fraction, so I don't have to put grouping symbol needed here. No, second square root of 15. Right. So my answer is approximately 4.75. Right, let me do the next one. Okay. Now, again, each problem here can be done using by hand computation. But again, I'm going to focus on calculator here. So let's do example 4. Again, I'm going to evaluate the expression here, z times sigma over e quantity squared, which give me sample size. So I'm notice that I have fraction, right? I have a numerator and I have a denominator. So I'm going to do multiplication and then division. So I'm going to type in 1.645 times 10.6 first. You can evaluate that in one step. You can also evaluate in 2 steps if you like. So I'm going to do it in 1 step. So in the numerator, I have 1.645. Oh, don't forget that the quantity square. I forgot the square here when they type it in. So let me do it. So I have big parenthesis, which is the red one, represent the red one. Now I'm going to do the numerator. The numerator, I'm putting one more, right? So I have 1.645 times 10.6 and close and divide over. The air is 1.2e, and the quantity, the whole thing square, so square. Okay, and that's approximately 211. All right, let's do the next one. Again, notice that before I do it, I like to write it in exactly how I write it in my calculator. So I'll do a square root, then I have inside a square root, I have a fraction. All right, so let's do it. So second square gives me square root. And on the numerator, I have 0.41. Again, I like to put the numerator in one parenthesis. So we'll have 0.41 times, again, 1 minus 0.41. I'm going to close that one. Close one more time. So my numerator is inside big parenthesis. And over the denominator, which is 300. Right? I would have the answer. I would suggest you try it out using your calculator, see if you get the same answer. Right? So the answer is approximately 0.0284. Notice that around the last 3 to a 4, because the next digit here is a 9, is more than 5. In this objective, second objective, we're going to evaluate a formula involving the plus and minus symbol. So when you have a plus and minus symbol, I'm going to have two answers. One is plus, one is minus. For example, when given a symbol x equal to x bar plus and minus zs, meaning that x1 is equal to x bar minus z times s is one of them, and x is equal to x bar plus 2 times z times s. So there's two answers here. So a good example here. So again, I'm going to, first step is I rewrite the plus and minus in two expressions. And then once I rewrite it in two expressions, then I evaluate each one separately. So at the end, you're going to have two answers. And oftentimes, the two answers, we write it in interval notation, right? As an interval, where at a smaller number on the left, the big number on the right. And this is interval notation here. All right, let's look at this example here, practice. So I want to evaluate x equal to x bar plus or minus ts. Again, plus or minus, I'm going to rewrite it into two cases, where x1 is equal to x bar minus t times s, x2 is equal to x bar plus ts. So I have two of them, right? So this is 2. So next time I'm going to substitute all of them into expression. We know x bar is 55.32 minus t is 2.065 times 7.82. Notice that when I substitute, I use a parenthesis around it to represent the multiplication here, so that way I don't confuse the decimal as multiplication sign. All right, let me plug in my calculator. Okay. Let me clear the window. So I got x1, I'm going to type in 55.32. Minus, I want my calculator to do the multiplication first, so I'll put a parenthesis around it. 2.065 times 7.82. 7.82. Okay. And that's how I got 39.17 approximately to decimal. I can evaluate the same thing for the other one. Now, if I want to write my answer in interval notation, I will write the smaller number first, which is x1. The minus is always smaller, and then the one with the plus. So in interval notation, I can write it as where the smaller number on left, which is 39.17, and the bigger number on the right, which is 71.43, right? That's interval notation. Okay. In the third objective, we're going to evaluate formulas involving the summation symbol. Now, this symbol here tells me to add up, summation, add them up. Now, depending on the textbook here, this type of symbol can be seen in the form here, I equal to 1 to n, tells me to evaluate, begin at first one all the way up to n. Now, some of them can also just write this way or this way, right? All three of them look exactly the same here. They can tell you do the same thing, right? In an effort to make the formula look simpler, many current textbooks use the third version. So this is the version that most of the time you'll see. I think in our textbook, we have the third version as well. Right, so what does that formula mean? So let's expand them. Right, so when I say summation of I equal to 1 to n power, meaning that I'm going to expand it, it will become x1 plus x2 plus x3 plus all of them until I hit up x to the n. Now this symbol alone tells me to add them up, add the terms up. Right, so note that I'm adding all the xi's here. Now, I equal to 1 is called an index. It tells us to start with I equal to 1. We don't have to start at 1, but typically in statistics, we will start at 1. Now, the n is the last term. Right? So the above formula telling us to add the terms of xi, starting I equal to 1 to I equal to n. So to be more specific, let's take an example here. If I equal to 1 to n equal to 3, then I would have x1 plus x2 plus x3. Notice that we stop at n equal to 3 here. And if we were given x1 equal to 4, x2 equal to 17, x3 equal to 8, then I would add up 4 plus 17 plus 8 equal to 29. And that's what this summation notation means. So the formula with summation can involve more complicated operations. So let's do one more example. So notice that if, for example, in chapter 6, we're going to start seeing mu is equal to x times pi, right? Now this is expanded out as what does it look like when we do it? So expanded. So we have x1 times p1 plus x2 times p2 plus x3 times p3 plus x4 times p4. Keep going until I hit the last term n, xn and pn. Now let's consider the example here. If a mu equal to xi times pi, I'm given x1, x2, x3, also p1, p2, p3. Notice that when I expand, it becomes x1, p1 plus x2, p2 plus x3, p3. I stop at 3 because the last term here is 3. So now I just plug it in and multiply. Now this here can be done in the calculator. Once you plug it in, substitute it, you just type in one step on your calculator. This step. Right, let me show you how to type that step in your calculator. Let me clear first. So I'm going to type 2 times, again, parentheses meaning multiply, 0.4 plus negative 3. Now, negative 3 is a negative number here, so I'm going to put a parenthesis around it, negative 3 times 0.35 plus 4 times 0.25. Right? So I will get 0.75. So mu equal to 0.75. But most importantly, always expand it first and substitute the value into the expression before you take out your calculator to start to evaluate. All right, let's do some practice. First, let's evaluate. First one, given mu xi pi, find mu if I know x1, x2, and p1, p2. All right, let's expand it first. So note that I stop at 2 and start at 1. So we'll have expanded become x1, p1 plus x2, p2. Now I substitute it. x1 is 5. p1 is 0.65 plus x2 is 11. And then p2 is 0.35. So I substitute it in and once and then just calculate it. But when you type in the calculator, you will get 0.71. All right, let's do one more. Practice 2. Now again, notice that my numerator and denominator both have summation notation in it. So first thing again, expand it. I'm going to evaluate the numerators first, then I will evaluate the denominator. Do them separately. All right, so let's expand it first. So for the numerator, summation xi fi. Now my x started 1 and my x3 is the last one. So I have 3 terms. So for x1 f1, x2 f2 plus x3 f3. Okay. So then add them all the terms up. In the denominator, I sum up all the fi's, which is f1 plus f2 plus f3. That's what this notation summation tells me to do here. Notice that since I have summation notation on top and bottom, so I express them out separately here. All right, let's substitute it in. So notice that first step, I substituted in. x1 is 18, so 18 times 5 f1. x2 times f2, x3 times f3, and the denominator f1 plus f2 plus f3. Now here, to evaluate, I can evaluate the numerator separately and denominator separately, then put them together. Right? So let me do the numerator first. The numerator is 18 times 5 plus 22 times, 22 times 12 plus 29 times 7, and that is the numerator, 557. The denominator is 5 plus 12 plus 7, so 5 plus 12 plus 7. Right? So at this step here, you can write down one extra step, 557 over 24. Right? So I can type 5. Let me write it out. So I have 557 over 24. You can type it out with 23.21 approximately. Here, you can type the number of 557 out, or you can use your calculator to retrieve the answer. So let's say I want to do 557 over 24. I can highlight it. Notice I use the arrow, highlight it, put enter, and then divide. Again, just use the arrow to get the answer 24 again, and enter, and then that. Now this trick is come handy if you have a repeated non-repeating decimal. That's a very wrong answer, long decimal answer. Instead of approximating, you could just highlight it and then enter to highlight it to get the number. Right? So that's 23.21. That's the final answer for this problem. Okay, let's do one more problem. So given the standard deviation S is equal to square root of this summation notation here, note that inside the square root, I have a numerator and a denominator. The numerator is in summation notation form. So first one is I'm going to expand it before I substitute the value into it. And notice that my x1, x2, and x3, meaning that I'm going to start n at n equals 3. So let me expand it. So this is equal to square root of, okay, I'm going to write the numerator inside the summation notation. So the numerator, I have x1 minus x bar square plus x2 minus x bar square plus x3 minus x bar square. And then in the, I made it a little longer. The denominator have n minus 1, n is 3, so 3 minus 1. You could substitute in for the denominator here, or you can just write n minus 1 here because I haven't substituted any value yet. Right? So now let's just substitute the numerator and evaluate. Right? So you can evaluate x1 for x1 is 3. So 3 minus x bar, which is 4. So 3 minus 4 square plus 7 minus 4 square. And then plus x3, which is 2 minus 4 quantity square. And that is the top. And in the denominator, I have 3 minus 2, which is 2 minus 1, which is 2. And this step here, I could just type in my calculator. I'm getting lazy. I don't want to just type it through by hand. So again, let's do it. So we'll have, again, second square. I can evaluate the thing inside first before I do square root, so that way it doesn't have to do so many square, right? So I can evaluate in 2 steps. So first, I'm going to do the numerator inside the square root. So 3 minus 4 square plus 7 minus 4 square plus 2 minus 4 and then square. That's the numerator inside the square root. Now that thing divided by 2, answer divided by 2, that is 7. And then I take the square root, so second square root of 7, right? And then I get the answer. So you can just say by square root of 7. You can also write 2.645 approximately. So that's the answer. Now let's do one more. Now here, this is a mixed practice of all the problems here. How about I just write you the answer and make sure you get the same one? All right, I'm gonna explain it. I'm gonna do one of the one that the most commonly missed in class. All right, A here, again, A here, when I say Z, nothing in between here tells me to multiply. So we'll say, be careful here when you type it in, the Z times square root of that whole thing. And when you multiply that out, the answer for this question is approximately 0.08. Now in part B, and watch out here. Now the T, between T times S over square of N, I will write it as T, right? T like the T. In this case is 1.669, right? Like this. Put it in a parenthesis. Now this is a multiply. So on your calculator, make sure you put a multiplication sign, and then do S. S is 5.75 over this means division here, and then square root of N. N is 35. And when you calculate that one, you get approximately 1.651, right? Notice I keep 3 decimal place here because none one of them can have 3 decimal. I just follow the one with the maximum here. And part C, if we evaluate it, again, this is a plus or minus here, like we did in the example. You will get plus. The plus will get negative 0.5345, and the minus we get about 7.2145, and I write them in interval notation. Right? Those are the one that here we kind of done before, similar problems. So let's do D. D is the one that in class, this is the most common missed one. Right? So let me first step, I'm going to substitute in. Notice that this summation notation is applied to the whole thing, right? It's not to the numerator, not to the denominator, but to the whole thing. So when I expand it, I'll write it as O1 minus E1 square over E1. Let me write it. So O1 minus E1 quantity square, right, over E1 plus O2 minus E2 quantity square over E2. I stop at 2 because this is the last term. Right? So now I just substitute it in and write it. So O1 is 15.3 minus E1, 20.3 quantity square over E1, which is 20.3 plus O2, which is 22.8 minus E2, 18.4 quantity square over E2, which is 18.4. Right? This part here, I can just type it in a calculator. So let's do it. Let me clear my window. Again, I'm going to write each fraction in one big parenthesis. We can evaluate each one separately, then write it down in different steps. Again, I'm going to do it in one step here. So I'm going to, okay, when I do one step, meaning I'm going to type the whole thing here in one fraction, one parenthesis, and the other whole thing here in a big parenthesis as well. Right, so let me do it. So this is the big parenthesis, the first one, and the second one here is the numerator, second parenthesis. So 15.3 minus 20.3. Oh, 20 here, not 20.3 quantity square over divide 20.3. Okay, 20.3 and close. That's the first fraction plus the second fraction. Okay, that's the big parenthesis here. The second, this is the numerator for the numerator, 22.8. Again, my calculator doesn't write it repeating. 22.8 minus 18.4 quantity square. Okay, divide 18.4, and this is the close the big parenthesis, hit enter. Right? So the answer is approximately 2.3. All right. Thank you for watching the video. I'll see you next time.